Welcome to the new chapter of Water under the Edges of Chemical Process Utilities. As we have discussed that water is an integral part of utility system in any chemical process operation. We can see that there are so many uses of water, whether slurry preparation, whether boiler feed water, whether sometime it gives you an idea about the steam. So water has enormous uses, and moreover water find its way in the chemical processes with respect to the utility just because its abundance in availability, cheap, etc. And water is also used as a heat transfer media in some of the cases. So let's have a look at what different type of topics we are going to cover in this particular lecture. First we will have a brief introduction, then we will discuss about various sources of water and water chemistry. Now importance of the sources of water is that because the large spectrum of water or large sources of water available as on date, groundwater, surface water, subsurface water, sea water, well water, etc. So we will discuss about all these sources with respect to their availability, with respect to the quality of the water. Then since water is having n number of sources, then definitely the different type of ingredients, different type of impurities, etc., they are also enormous in the water source. Like river water or spring water or a lake water is entirely different from what the water available in the sea source. So in this particular aspect we will discuss about the chemistry, water chemistry, because ultimately the knowledge about the chemistry is again important in view of the fact that we cannot use water as such. Even if we are using the drinking water, then again it needs to be purified before it becomes the potable water. Similarly, if we are using the water as a source of diluent, then in that case we need to remove certain impurities. So the chemistry of knowledge about the chemistry of water is quite essential. When we go for the introductory part, we all know that pure water is colorless, odorless and tasteless, and there is a basic chemistry. It composed of hydrogen and oxygen. Now because water becomes contaminated by the substance with which it comes into contact, it is not available for use in its pure state. One of the reasons, just for the sake of an example, that if water is coming from the Himalayas or take the Ganges water, then it is passing through various surfaces and it may get contaminated, it may have certain other impurities. So it may not be useful for the variety of the purposes which we discussed earlier. So therefore it is said that it is not available for use in its pure form. To some degree we can say that water can dissolve every naturally occurring substance on the earth because it is a very good solvent. Now because of this property of the solvency, the water has termed as a universal solvent, and sometimes it is quite useful and sometimes it is quite disadvantageous. We will discuss this particular aspect in due course of time. Although the solvency power is beneficial to the mankind, but it poses a major threat to the industrial equipments. In virtually all domestic and industrial processes in which untreated water is heated, the fouling of equipment is the most serious problem encountered. And by this way, the energy efficiency or economical aspects of those equipments are on the negative sides. So let us have a brief look about the affected application area. These may be included laundry, dairy, dishwashing, cooling, boiler feed water, geothermal power generation, semiconductor and other production processes. So this can badly affect the impurity of the water or hardness of the water can badly impact all these operations. These are the generalized operation. We will discuss some specific operation in due course of time. Now a mineral scale usually is defined as a deposit of certain sparingly soluble salts. such as calcium carbonates, calcium phosphate, calcium sulfates from the process fluids after precipitation into the tubing and other process surface. So, in over the period of time it may get deposited the inner surface, and the energy efficiency problem with the malfunctioning of the equipment may take place. So, these deposits generally include the various solvents like corrosion products, microbiological, colloidal or suspended manner. Now, one of the example is the fouling of heat exchanger or reverse osmosis membrane. Usually, it's a complex phenomena. This involves the deposition of several different but related type of foulants. So, we need to look into, like if we take the reverse of osmosis membrane, different type of fouling may create a problem, and the efficiency of these membranes may deteriorate over the period of time. So, this not only adversely affect the energy efficiency of the system, but also it creates the economical problem, and sometimes replacement of these membranes etc. may take place. So, we need to address such kind of inherent property of the water. Now, since briefly we had discussed about the water, and we all know that water is extremely important for the chemical processes. So, let us have a look about the different sources of water. Almost 97% of the earth is submerged with the seawater, but we can't use this seawater as such. So, the first source which we are going to discuss is the seawater. The solids in seawater come from two sources: the chemical weathering of rock washed into the seas by rivers, and water circulation through hydrothermal vents, that is called the hot spring. The major dissolved constituent of seawater are the same as those encountered in natural waters. So, average salinity of seawater is almost 35%. This is again very high. Another source of water is the lake water. Now, generally the composition of lake water is affected by seasonal changes and sometimes daily due to the variation in the weather condition. Above all, the source of water is again important in case of the composition of lake water. The most of the dissolved mineral constituents may not be greatly affected by seasons, weathers, and various factors such as dissolved oxygen, temperature, suspended solids, turbidity, carbon dioxide. They may be influenced by the various biological activities. So, stagnancy also plays a very vital role because it promotes the biological activity of the lake water. Another is the surface water. The contaminants in the surface water depends on the nature of the terrain over which it flows. Maybe river, maybe some tributaries of the river, maybe canal, etc. So, in areas those who are consisting of hard packed clay, the very little water penetrates the ground. In these cases, the water generates a runoff. Although several factors can affect a surface runoff, the extent of runoff is usually a function of rock and soil types, climate, precipitation, saturation, vegetation and time. So, all these parameters they are usually pose effect on the surface runoff. Porous materials like sand, gravels and soluble rocks absorbs water far more readily than does fine grained dense clay or unfractured rock. A poorly drained material, usually they are termed as non-porous, has a higher runoff potential resulting in greater drainage density. Rivers usually carry the dissolved ions they receive from the ground and surface runoff to the sea. Now, apart from this river, when we are talking about the river, there may be certain other inherent contamination, maybe due to the discharge of municipal corporation or some other discharge from small villages, etc. They also may become the contaminated part of those waters. Now, when we were talking about the dissolved ions, so these dissolved ions include sodium, potassium, calcium, magnesium, SCO3, CO3, chloride, etc. Now, the total dissolved solids in rivers are about 100 milligram per liter. These figures may vary. Now, rivers also carry small particles of rocks and mineral. Though over the period of time, they may get grind and then may become the part and parcel of the surface water. Also, they may become the total dissolved solid or total undissolved solids or total suspended solids, etc. Now, many surface water supplies also contain organic material which may occur either naturally or as a result of a human intervention. As we were discussing that sometimes these river water may get contaminated by the sewage, may contaminated by some industrial effluents, etc. So, all these things they are clubbed and they may become the contaminants to the river water. Various kinds of tannins and lignins resulting from the decomposition of vegetations. They are also the colloidal form the colloidal suspension or the dissolved compound present in the surface water. It may create a problem, and therefore identification and removal of all these are again very important. Now, when we are talking about the surface water, some debris, some animal debris or other debris, they also become the contaminant part in the surface water. Now, let us have a look about the subsurface water. Now, it is fresh water located in pore space of soils and rocks. Now, it is generally recognized that underground water usually moves very slowly. Its flow is measured in feet per year. Compare this the surface stream where velocities are in feet per second range. So, the migration of these water is very slow, or water bodies are very slow. Now, because of these slow movement, the composition of any well is usually quite constant. So, this is again you can say it is in one way it is a very plus point that it gives you a dependable supply of water, in which you can rest assured or you can design the things in a stable manner. Now, let us go to the water chemistry, and again we will come back about the different sources of water in due course of time. Now, the impurities in water, these can be classified into different categories. So, we have enlisted 5 broad categories. Number 1, that is the dissolved inorganic compound such as bicarbonates, carbonates, sulfates, fluorides of calcium, magnesium, barium, strontium, and small amount of iron, manganese, aluminum and other substances. Number 2 category is the dissolved organic compound such as humic acid, fulvic acid, tannins, insoluble organic matters such as leaves, dead bacteria, stems and other biological product and industrial wastes. Now, third category, the gases such as oxygen, nitrogen, carbon dioxide, sulfur dioxide, hydrogen sulfide, methane absorbed from the atmosphere and subsurface sources. Now, the knowledge and sometimes removal of these gases are quite essential, just because if they become the part and parcel of your process, then either they may create a problem for the chemical reactions, and moreover if they are used as a source for steam production or a boiler feed water, sometimes they may create the problem of falling, may create a problem of foaming, etc. And we know that foam does not carry any kind of heating value, it may hinders the further processes. Now, the fourth category is the suspended matter such as clay, silt, oil, fat and greases. And the last category that is again very important, that is called the microorganism such as bacteria, algae, fungi, etc. So we need to look into these things, and before processing these waters we must identify the basic chemistry of the water which is in question, and try to adopt the proper methodology for the removal of such kind of impurities if needed. Now let us have a look about the physical chemistry of water. First one in this category is color, because color may be just because of various kind of constituent present in the water, and it is a human perception that always we look for the colorless water. But if there is some coloring compound, then it quite obvious that we are not going to accept it. So the color, this is dissolved organic materials from decaying vegetation and certain dissolved inorganic or organic compound, they may cause color in the water. Now another physical phenomena is detergency. Many natural and synthetic substances may cause foam when water is agitated, and agitation of water is quite common in the chemical engineering phenomena. The major cause of foaming is surfactant, that means the alteration of surface tension or surface energy, which may be which are usually created by synthetic chemicals. They are used in detergent. Now foaming substances can be removed by a conventional treatment consisting of sedimentation, coagulation or flocculation, and filtration or activated carbon. Another very important thing, as we discussed, that water is odorless. So odor in the water can be caused by foreign matter such as organic compound, inorganic salt, and dissolved gases. So off odor sometimes create a problem, and sometimes we look into these aspects to prevent the problems in the future chemical processes. Another thing is which we need to look is that is temperature. Now temperature is important in determining the rate at which scale forming salt precipitate on heat exchanger or reverse osmosis membrane or equipment surface, and thereby to the extent to which these salts could become a major falling problem. And once they are creating the falling problem, then obviously the issue pertaining to the wear and tear, issue pertaining to the energy efficiency or economic aspect always come forward. Now in desalination by reverse osmosis, the temperature is extremely important in determining the pressure drop through the membrane at the intended flux rate. So therefore this is again a very important thing which we need to look. Now next is turbidity. Turbidity in water is usually due to the presence of suspended solid dispersed throughout the water, and is a measure of extent to which light is scattered by the suspended solid such as clay, silt, organic matter, by the plankton and other microscopic organism that interfere with the passage of light through water. And above all, this turbidity is closely related to the total suspended solid, but also includes plankton and other organisms, and is measured in nephelometric turbidity units or referred as NTU. So this is again important thing, because everywhere when we talk about the turbidity, order, coloring compound, again there is a chemical intervention, and this need to be addressed a priori before we go for any chemical processes. Now water containing suspended matter is again a serious problem, and it creates it may be attributed to the several reasons. It protects the microorganism from chlorine and other biocides. It interferes with the test for coliform bacteria. It interferes with the maintenance of residual chlorine, and it acts as a food source for microorganisms, allowing them to survive and multiply. Therefore, excessive turbidity must be removed by the filtration. And because again I am coming back to the human perception that always look for the clear water. So, turbidity of any kind is usually not acceptable. Now, let us have a look about the chemical aspect under the edges of water chemistry. So, first is the aluminum. Now, aluminum based compounds such as sodium aluminate, aluminum sulfate, they have been used for years as a coagulant aids to clarify industrial and municipal waters. Now, these flocculant agents hydrolyze to form insoluble hydroxides and neutralize the charge of turbidity particles in water. So, in most of the cases, these large particles, they are removed via settling in a clarifier and collected as sludge. Time to time fluctuations in pH at the water treatment plant, they cause the excessive amount of aluminum to pass into the distribution system, usually in the dissolved form. Further, if pH adjustment is required to control calcium carbonate scaling, aluminum hydroxide may precipitate and deposit on the heat exchanger and RO membrane surfaces. Another chemical which is very important, that is the barium. Barium is a divalent ion which forms insoluble salts with sulfate ions that is soluble to the level of less than 1 milligram per liter. So, like calcium ions, barium ion also form insoluble salts with fluoride ions. Now, next is the calcium. Calcium is always present as divalent ion that form insoluble salts with various anions such as carbonate, fluoride, oxalate, phosphate, polyphosphates, etc. So, under certain conditions, calcium ion also form insoluble salts with organophosphate compounds and acrylic and maleic acid based polymers commonly used to prevent the precipitation of calcium based salt in industrial water system. Another common metal is copper. Now, copper is found in some natural waters, particularly in area where copper has been mined, and presence of copper especially in recirculating water may be due to the corrosion of copper or copper based alloy used in the pipe. So, especially when we use water for as a feed water for the boiler, we must look into this thing. Apart from this, copper is again a very good catalyst for various catalytic operation. So, if we are using the water for any kind of chemical reaction thing, then we need to look, we need to analyze the presence of copper. Otherwise, it may create a problem, it may catalyze the or it may unwanted catalyze the reaction. Another important thing is the chromium. So, many chromium compounds are relatively water insoluble. The metal industry mainly discharges trivalent chromium. Hexavalent chromium in industrial wastewater mainly originates from tanning, painting and other allied industries, and it is a serious problem in all those chemical industries. Now, chromium in seawater varies strongly, and it usually 0.2 to 0.5 ppb or the parts per billion. Rivers contain approximately 1 ppb of chromium, although strongly increased concentrations are sometimes possible. Another very important is the iron, and usually it found in the surface water, subsurface water, etc. So, you can say that among the various dissolved impurities in natural waters, iron based compound cause the most serious problem in the efficient operation of industrial water system. Again, it's a very good catalytic thing. So, in the reduced state, iron 2 or a ferrous 2 plus ion are very soluble and pose no serious problem, especially at low pH values. However, upon contact with the air, Fe2 plus ions are oxidized to a higher valence state, Fe3 plus, and readily undergo hydrolysis to form insoluble hydroxides. Iron at low concentration exhibits a negative influence on the performance of scale inhibitors. Another important metal is magnesium. Magnesium forms sparingly soluble salts such as magnesium silicate and under high pH condition magnesium hydroxide. Now both are common in cooling and boiler system. So before we use water for these systems or these operations, we need to look at this particular aspect. Manganese. Manganese is usually present below 0.5 milligram per liter in public water supplies. Private water supplies often contains higher manganese level and mostly in a dissolved form that participates as hydroxide on exposure to oxygen. Sodium. Usually a sodium ion is monovalent, so it forms relatively soluble salt with most ions including bicarbonates, carbonates, sulfates and chlorides. Therefore, seldom presents a scaling problem in desalination and cooling water system. Potassium. Potassium, although chemically similar to sodium, potassium is not likely to present in appreciable amount in a water supply. No operating or scaling problem are caused by potassium ion in industrial water system. Now silica is another component. Silica often limits to the extent to which water can be used in cooling and RO system. Although true solubility level of silica is affected by various factors like pH, temperature, TDS, etc. The maximum silica concentration is customarily given as 150 milligram per liter, although it is sometimes dictated by the various regulatory bodies like Central Pollution Control Board or environmental regulators of different states. Let us have a look about the bicarbonates. Bicarbonate ions do not form insoluble salts. However, a portion of bicarbonate on exposure to a high pH and temperature and under the conditions of high cycle of concentration can be converted to carbonate ions and resulting in calcium carbonate. Now such cases require the addition of an acid or scale inhibitor to prevent the precipitation and deposition of a calcium carbonate on equipment surface. So again the problem of scaling, problem of low energy efficiency, problem of wear and tear, all these things may take place. Let us have a look about the carbonate. Now carbonate forms insoluble salts with calcium and iron ions, which are usually we discussed previously, and it can precipitate to form scale deposition on various RO membranes and heat exchanging surfaces. Now carbonate based deposits, they are normally controlled by reducing the water pH or adding a scale inhibitor to the feed water. Now let us discuss about the chloride. Most waters contain chlorides. It can caused by leaching of marine sedimentary deposits and by pollution from seawater, brine or industrial wastes. Now an increase in chloride content may indicate possibly pollution from sewage source, particularly if the normal chloride content is known to be low. Now chloride is relatively safe It has neither any negative effect on the life of RO membrane or does it generate insoluble salts. Now, a brief discussion about the fluoride. Fluoride is sometimes poses various health issues. So, fluoride level in water vary according to the source. With seawater is having the maximum amount of fluoride, then groundwater, then surface water. Now, fluoride ion do not directly affect either an RO membrane or heat exchangers, but form soluble salt with the barium, calcium, magnesium, strontium, etc. So, the precipitation of fluoride based salt should be carried out by adding a scale inhibitor to the feed water. Sulfate. Water containing high level of sulfate caused by leaching of natural deposits of magnesium sulfate or sodium sulfate may cause a scaling problem due to the formation of insoluble salts with calcium, barium and strontium. Now, let us have a look about the oxygen. Water void of oxygen are likely to contain soluble iron, manganese and hydrogen sulfide. Now, upon exposure of these waters to oxygen precipitates, they are likely to form and may cause serious operation problem, which briefly we had discussed at the start of this lecture. There are certain organic chemicals. Organic chemicals, they are includes like pesticides, herbicides, different type of trihalomethanes, volatile synthetic organics, etc. Now, maximum contaminants level of several common pesticides and herbicides, they have been already established. Now, in this particular chapter or in this particular lecture, we have discussed about the different sources of water and what are the different contaminants present in the water in a broad spectrum or a theoretical aspect. Now, if you wish to refer further, then we have enlisted couple of references in this particular slide. You can have a look and you can see, you can go into the detail. Thank you very much.